So in this short video tutorial, I'm going to be talking about viscosity. Viscosity is very important on a CIJ, a continuous inkjet, because the process in which we are splitting the droplets of ink from a continuous stream is very precise. We use an oscillator, a crystal that is oscillating at 65,000 hertz. So that is basically splitting that stream into 65,000 droplets per second. So if the ink is too thick, we're going to have a very poor drop breakup. And if it's too thin, we're going to end up with satelliting again, a very poor drop breakup. So we need to make sure that the viscosity is set just right. We measure viscosity in centipoise. So if you look at the main screen and you see target viscosity 4.5 cp, that's centipoise. So we're looking for a target of 4.5. Either side of 4.5, you're allowed to go up to, or the acceptable limits is 0.5 either way. So if you go down to 4, then you'll still have pretty good print quality. If you go up to 5, you'll also have pretty good print quality. Anything outside of that range, you've got to start looking at the machine and start seeing why you're not getting that issue. A lot of things that can cause bad viscosity, just ambient temperature, heat, moisture in the ink, humidity. So there's a lot of things that can cause the viscosity to go out of range. Solenoid valves blocking up that are now putting more makeup into the ink tank. So the way we measure this is with a part called a viscometer. The viscometer is a very simple glass tube with a little ball bearing in it. We open up a solenoid valve, we fill that glass tube with ink, and then we switch off the solenoid valve and we time how long that ball bearing takes to fall. At a certain time, if the ink is too thick or too thin, it will either be too slow or too fast. So we're looking for that 4.5 range. So every now and then the viscometer does need cleaning, especially on some inks. It causes a scaling in that glass tube. So it is possible that over a period of time, I'm talking many years, like 4 or 5 years, it's possible that that glass tube starts interfering with how fast that ball bearing comes down. So this tutorial, I'm going to show you where the viscometer is and how to clean it. So we're going to turn the printer around and get at the access to the rear panel. Slide this rear panel off. So the actual viscometer is on this side, on the side of the makeup tank, and you can see it right there. The little module has 2 tubes coming to it, plus a couple of cables at the back there. So to get to it, we've got to take all this tank out, okay? So let me run through the tools that you need for this job. Okay, so the tools you need for this job, obviously you need the cleaner, because we're going to be cleaning that glass tube and the solenoid valve, and that's the base of that cleaner is the same as your printer. So if you're using an MEK based printer, then you need an MEK based cleaner. Then you've got your beaker. You need a large flat bladed screwdriver to open the front door of the cabinet. You need a torque wrench, a T10 Torx wrench, and a Phillips bladed screwdriver, and then obviously your PPE gear, your glasses, and your latex gloves. Okay, so coming back to the printer, we need to take out this smart fill, the makeup smart fill cup. So I'm going to take the cap off, grab my Phillips bladed screwdriver, and we have 3 screws as before in other tutorials. We take those out, careful not to drop them, lose them. They are very small. So once these 3 screws are out, then you can go ahead and lift out this whole smart fill cup unit. And that gives us access now to the makeup tank. So now I'm going to put my little working platform in. And this does slide out. Now the makeup tank slides out. It is quite a tight fit. But it's pretty easy to get out. So now, as you can see, we've got complete access here to the Viscometer. And this held on by two little torque screws here. We're going to use a T10 torque wrench to remove these two screws. And they're just self-threading screws that go into the body of the makeup tank. So that comes off pretty easy. We can go ahead and slide the makeup tank back in, out of the way. And then that leaves here the Viscometer. Make a note of the tube connections. So here at the bottom we have the purple or the violet, and the top we have the brown, and then on the top here we have also the gray. Then we have the solenoid connection on the end here, and then the actual sensor that is measuring the glass tube. This here is your glass tube, and this is where we're measuring the speed of that ball bearing. So we're going to take all this out so we got better access to it. I'm going to put my PPE gloves on. Okay, now I've got my gloves on, I'm going to start taking some tubes out of here. Remember also to have this unit switched off. So these are compression fitting tubes. So what we're going to do is we're going to push in on the compression and then just slide the tube out. Obviously wear your safety glasses. And then what I normally do is I'm just going to tuck this up out of the way for now so it doesn't splatter ink everywhere. Do the same with the brown. Gently pull that out. Tuck that one up in the same place. Held up out the way. And then we're going to do the same with the gray tube on the back here. Slide that one out. Hold that out the way. Okay, so now we have all the tubes off. We can see nice and easy to get at. Solenoid on the back here. Glass tube. Now the glass tube is going to have ink in, so don't just go ahead and take all this off. You have to drain the ink out, and there is actually a little drain screw at the bottom here. So get a beaker, Phillips screwdriver, undo this screw, and drain the ink out under a controlled means. Now there is going to be more ink than that. I already drained it out. So drain the ink out. When the ink is out, you'll see the glass tube is going to be clear. What we can do now is we can actually take the cleaner in the top hole, squirt down into the glass tube, and you see over a beaker, you see everything cleaning out. And you see when we release the cleaner, you see the tube filling up with cleaner. Let that clean out. Keep cleaning it out like that. So filling it with cleaner. Until you see the glass tube is nice and clear. Let that drain out. Okay, dry off. Now when we move it, you see right there, you see the glass, the ball bearing. That's moving nice and freely backwards and forwards. So I would say we've got that pretty clean. The only other thing to do while this is off is to check the solenoid valve, and it's the same process as we did the solenoid valve in the early tutorials. We'll take this off now, and again it's just 2 screws as per the other solenoids. There is going to be a little residual ink in there, so when you take this off it will weep a little bit of cleaner now, but ink. Take this one off of here. Okay. Put the screws down. So what I'm going to do now is clean the solenoid valve, and we're just going to clean it around. And then, as per before, you can go into the tutorial for cleaning solenoids, start the printer up, open up the valve, and then you can actually clean this valve with it open then. Once it's clean, we can go ahead and bolt it straight back on. Don't over tighten these screws. They are going into the plastic, so very easy to strip those threads. So just cinch them down. Then we can go ahead and put this screw back in for the drain. Clean off the outside. And then refitting is the opposite of taking it out. So we're going to put the tubes back in first, and the tubes go in order. So the purple in the bottom, brown into the top, push in until you hear that click, and then the gray into the top here, like that. Everything's back in place. We can lift the tank out, and then using these 2 screws, remember the T10 Torx, one. That's another. We can go ahead and slide the makeup tank back in, making sure we don't trap any of the cables, like that. Once the tank's in, we can go ahead and put the smart fill cup back in. Again, making sure there's no cables get trapped. Remember the trick of loading this in here. Just spray a little bit of cleaner around, and that lubricates the plastic. It slides in a lot easier. And then just the 3 screws go back into the top here. Put the cap back on, and we are ready to fire it back up and load that Viscometer full of ink again. Okay, so to test the solenoid valve on the Viscometer from the home screen, we're going to go into Service, and we're going to go into Fluidic, and we're looking for valve 5, which is the Viscometer. And I can press it on and off, and I can hear the click inside the printer. So to see whether the Viscometer is working properly, what we're going to do is we're going to go into Service, and we're going to Start. And then at the bottom here, you see Viscosity Status None. It says Target 4.5 centipoid. Actual is 0.0. So now what we're going to be doing, now the jet is starting, it's going to take some time, but you will see the viscosity status will start counting down. And the countdown is basically the solenoid opening up, it filling with ink, and then the solenoid valve closes, which allows the metal ball to drop down in the ink, and it will take that time and calculate the viscosity from that. So now you see we're in green status, and its viscosity status is weight 172, 171, etc. So now when this is calculated, all this, and it takes about 5 minutes, but once this is all calculated, it will come up with an actual viscosity. So now, as you can see, it's coming down. Weight is 4, 3, and after it's counted down, you heard the solenoid click over, and now it's actually. So now from sample, it's counting down 4, 3, 2, 1, and now it's actually measuring the ball coming down the glass tube. And this will count how many seconds from the top to the bottom, and it will calculate then the viscosity. So it took 80.2 seconds for the ball to drop, and the calculated at actual viscosity is 4.4. As you can see now, it's waiting a time span to do the calculation again. It will come to sample. That will open up the solenoid and allow ink into the glass tube, and then it will measure the ball bearing coming down the glass tube, and that calculation in seconds will give you the actual viscosity. So 4.4, we're all accurate. We're right on schedule there to start printing, and away we go.